Today's daily LeetCode problem of the day is integer to English word number 273. For this problem, we simply want to convert a non-negative integer num to its English word representation. So, for example, the number 123, we want to output 123. For the number 12,345, we want to output 12,345. Pretty simple. For this problem, we're going to take a recursive approach because I think that's what was intended. Yeah, it's supposed to be recursive. And realistically, these are all the possible cases in the problem. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 19. And then we have 20, 30, 40, 50, 60, 70, 80, 90, 100, 1,000, million, and billion. Realistically, using just this set of numbers, we can craft our output, because if it's 2 billion, for example, we can just divide it by 1 billion and it will result in 2. And then we could do 2 and then the word billion, so on and so forth. So how are we going to do this? First thing we're going to do is we're going to identify string arrays, and these string arrays are going to store our values. So if our values are below 10, they're going to contain from 0 to 9. If they're below 20, they're going to contain between 10 and 19. And if they're below 100, they're going to contain between 0 to 10, 20, 30, 40, 50 to 90. So let's go ahead and define these strings real quick. I already had them typed out, but this is what we basically need. A below 10 example, a below 20 example, and a below 100 example. And that will give us all of the possible combinations of numbers that we are going to need to craft our solution. So if you need to, you can pause and copy this. I used public instead of private or static because this is the only class in our problem. There's no need to make it private to this class. There's no need to make it static for each method, as we're only going to use it in one method. So we don't plan on making any changes to it, so I'm just going to leave it as a public string. You can make it final in case you want to. Be careful not to change it, but we are not going to intend to change this array whatsoever. So after we identify all the possible word cases in our problem, there is a base case that would require us to exit early. So if our number is equal to 0, we're simply going to return the word 0 because we are not including 0 in these examples. That is because if we have 1 million, we don't want to do 1 million and 0. We just want to do 1 million. So like, for example, if we have 1,000, we don't want 1,000 and 0, just 1,000. So after we identify our base case, if number is equal to 0, we are going to call to a helper function. So we're going to return our helper function. We could call it helper func. In our helper function, we're simply going to pass our number, and this is going to be the recursive method. So this can be a private, and it's going to return string, and then it's called a helper func. It's going to receive a integer num. So in this function, we are going to pass our number. After passing our number, we are going to identify, is this number less than 10? If so, we can call to our below 10. If it's less than 20, we can call to our below 20. If it's less than 100, we can call to our below 100. If it's less than 1,000, we want to divide it by 100, so we could get, for example, if it's 1,000, we can get divided by 100 and we'll get 1. If it's 9,000, we'll divide it by 100 and we'll get 9. So let's go ahead and start implementing this. It's going to be a set of if statements. So we're going to have if num is less than 10, we can return, and then we're going to call to below 10, and it's going to be below 10 of num. So let's say the number is 8. 8 is less than 10. So we're going to look at 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's simply going to return 8. Then we could do if our number is less than 20. We're going to call to below 20. So return below 20. And we're going to return below 20 of num minus 10. So why are we doing num minus 10? So if we look at this and our number is 19, for example, 19 minus 10 is 9. So if we look at below 20, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is 19. So we're calling to a specific index in below 20, and these indexes go from 0, 1, 2, 3, 4, 5, 6, 7, 8 to 9. So it's a length of 10. So if we subtract 10, we are going to get the index that we want to get. Then we're going to have if num is less than 100, we can do return below 100 of this one. We're going to do num divided by 10, because if it's 80, 80 divided by 10 is 8. And that will return 80. So num divided by 10, and then we're going to add, because if it's 85, we don't just want to return 80. So we're going to add our num percent 10. So whatever num percent 10 is, as long as it's not equal to 0. So as long as it's not equal to 0, we're going to add a space, and then we're going to add another helper function. So we have below 100 of num divided by 10. So let's say we have 77. So this is going to return 7, below 100 of 7. So it's going to return 70 plus num percent 10. So num percent 10, we have 77 for this example. Percent 10 will equal us this second 7. So num percent 10 is not equal to 0. So we're going to add a space. Plus, we're also going to call back to our helper function. So helper func. And then we're going to pass it num percent 10. Otherwise, if num percent 10 is equal to 0, we can simply return an empty space, or a close to our string. So helper func is going to look at num percent 10. Num percent 10 is equal to 7. So it's going to go back up here. If num is less than 10, it is. So then we're going to have 77. That's it. Next case scenario is if num is less than 1,000. So from anywhere from 100 to 999. We're going to return, and we're going to call back to our function because we don't have 1,000, 2,000, 3,000 listed. So we're going to call helper func, and we're going to pass it our number divided by 100. Because 1,000, for example, is not like 10,000 currently. We will have to address 10,000. But we're looking just at 1,000. Actually, sorry, we're looking anything under 1,000. So we have 100 and 999. So 100, 200, 300, 400, 500, like that. So we can call back to our helper function, divide it by 100. It will run through this if statement. So we'll return whatever the number is. So if it's 100, it will return 1. And then down here, we can add the 100. So 100. And then we can check if the rest of our number is zeros. So if num percent 100 is not equal to a 0, we're going to add a space and then call to our helper function again. So helper func, and we're going to pass it num percent 100. That is basically going to slowly, recursively travel through the number and make it smaller and smaller into manageable pieces where it can be addressed by these three case scenarios. If it's going to be a 1, a 10, or a 10, 20, 30, 40. So this is our 1,000 case scenario. Our next case scenario would be if it's between 1,000 and 1 million, or 999,999. So if our num is less than 1 million, so that's 100,000, 10,000, 100,000, 1 million, we're going to return our helper function again. It's going to be the same thing, except our num is going to be divided by 1,000 this time, because the max we could go to is 999,000. So we're going to divide it by 1,000 plus 1,000 plus, we're going to check if the rest of the numbers is zeros or not. So num percent 1,000 is not equal to 0. If not, we can add a space and then call to our helper function again with a smaller number. So num percent 1,000. Otherwise, we will return the end of the string. So that is our 1 million case scenario. Then we're going to move on to our next one, as long as it's greater than 1 million. So if num is less than 1 billion, so 100,000, 10,000, 100,000, 1 million, 10 million, 100 million, 1 billion, we're going to return our helper function again. So helper func. So this is anywhere between 1 million and 999 million. So we're going to have num divided by 1 million. So 1,000, 10,000, 100,000, 1 million. Then we can add that to the word million and go back through our helper function again. So num percent 1 million. As long as it's not equal to 0, we can add a space and then call to our helper function, passing it a smaller number. Otherwise, end our string. Now, this case scenario does go up to the billions. However, we do not need a if statement for that, because the statement itself is an if statement using the question mark as an if statement and the colon as an else statement. So we can simply return, we can call to our helper func, and then pass it num divided by 1 billion. So as long as num divided by 1 billion, if this is the case, we'll put billion. And the only reason we would do that is if it was qualified to reach that, because in every other situation, it will return our function. It should never really reach down here unless it does have a billion. It's greater than a billion or equal to a billion. So num percent 1 billion, or sorry, this is 1 billion, is not equal to 0. Add space, call to our helper func again, num percent 1 billion. Otherwise, end our string there. So these are all the possible case scenarios. For our 10, 20, and 100, we are going to be able to access these arrays directly. For anything greater than 100, we're going to call back to our helper function recursively, make the number smaller, and it will use one of these. So if it's 10,000, or if it's 1,000, or if it's 100,000, this should take care of that, because if it's in the hundreds, it will go 100, and then if it's in 1,000, it will go 1,000. So if we run this, passes our test cases, and if we submit it, passes our solutions. Let's go ahead and do this in Python. So our problem in Python is pretty much the same. We're going to have the global variables that are going to represent our string arrays, and then we're going to have our conditions in our helper function. So our first string array is going to be below 10. It's going to be equal to an array consisting of empty string to 9, and then below 20 is from 10 to 19, and then below 100 is 10, 20 to 90. So now that we have those, you could pause and copy it if you'd like. We're simply going to base our test cases. So if our num is equal to 0, we can return 0. Otherwise, we are going to return self dot. We're going to have our helper func. We're going to pass it num. Then we can define this function, helper func, which is going to return self and num. So in this helper function, we simply just need to go through our test cases once again. So if num is less than 10, return self dot below 10. If num is less than 20, return self dot below 20. Sorry. Of num minus 10. And then if num is below 100, we will return self dot below 100 of num divided by 10. Plus, again, we have to check to make sure that there is no other numbers after it. So we're going to have plus, and then we're going to address the small number. So if num percent 10 is equal to 0, so in this case it's easier to say empty if it's equal to 0. Else we'll have a space plus self dot helper func of num percent 10. That's it. We just have to do that for the rest of our numbers again. So if our num is less than 1,000, return self dot helper func of num divided by 100 plus 100 plus blank if num percent 100 is equal to 0, else space plus self dot helper func of num percent 100 if num is less than 1,000. Ooh, whoops, this should be 1,000, and then this should be 1,000,000. Return self dot helper func of num divided by 1,000 plus 1,000 plus empty if num percent 1,000 is equal to 0, else space So if we passes our test cases, and if we submit it, passes our solutions. So thank you. Follow for more daily LeetCode solutions.